Okay, question 7 was the small ring problem, which I've asked on some variation of on pretty much every one of the sample exams. And again here, because it's an important piece of the puzzle of understanding why reactions happen. Okay, so one, we have not talked about mechanisms at this time. So you've seen the SM2 reaction by now, so now you know kind of how this works. That was not the question here. The question here is, why is it reactive in the first place? What's wrong with the three-membered ring that it's going to open? So this is what used to be my three-membered ring. There's my two carbons and the oxygen. This bond breaks because the oxygen of the alcohol comes in. Now, that's how. Why? Why does that happen? When we went through the problems with small rings earlier, they're all going to apply here. 1, this is a constantly eclipsed conformation that it cannot escape. 2, the bonding orbitals are not on the straight lines I have drawn here. The overlapping of the bonding orbitals for those atoms should be 109 degrees apart. An equilateral triangle is 60 degrees. So something here's got to give, and what it is the overlap of those atoms. Bonds in a small ring are inherently weaker because it's not a good overlap of the bonding orbitals. 3, in this case, we have a polarized carbon-to-oxygen bond because of electronegativity. All of those things put together means we have a structure that is reactive. It's going to break that ring open. You didn't have to know where. I didn't even have to give you an example of why. I could have just left you that three-membered ring only and said, okay, why is anything ever going to happen here? That's the point of this question. 1, you have the strain of being eclipsed. 2, you have the strain of bad overlap, or so-called angle strain. 3, you have polarization because the oxygen is much more electronegative than carbon. All of those make epoxides very, very reactive.